Welcome to a webinar about EtherCAT diagnostics, and in the next 30 minutes I will try to give an overview about the different EtherCAT diagnosis features, mainly of course in the TwinCAT system. If you have questions, feel free to ask the questions in the question window, and we will try to answer the questions during the webinar or at the end of the webinar. So the agenda for today is to give you a general introduction to EtherCAT diagnostic features, especially what is a working counter, what is a CRC, and so on, and then to show you different ways to do efficient diagnostics with TwinCAT system. And of course we will end up with a summary. So first of all, TwinCAT or EtherCAT diagnosis is separated in two different parts. So we have process data diagnosis, which is mainly done with the working counter, and we have the bus diagnosis, so the frame diagnosis, which is done with the CRC or frame check sequence at the end of a frame. So at the bottom you see a frame which is built up with an Ethernet header and ends up with a frame check sequence. So in more detail you see, okay, we have a standard Ethernet frame. We have according to IEEE 802.3. So that we start with an Ethernet header, then we have an EtherCAT header, and then we have different datagrams, which are kind of sub-datagrams inside an Ethernet frame. They all start with an own header, so it's a datagram header with data in the datagram, and they end up with a working counter. And at the end of the complete frame, we have the frame check sequence, which is mainly a CRC, so 16-bit CRC. When we do EtherCAT diagnosis, we have every cycle, so synchronous to the cycle of the PLC, for example, we see working counter. So this is actual with the incoming frame into the master, and it checks the reading and or writing of process data in every slave. And the reaction of working counter error has to be done in the application. So you have to decide what to do if there is a working counter error, if you stop your application, if you wait for the next cycle, and so on. Asynchronous, also not in every cycle, event triggered, we can get the master state, which has a defined state machine. Inside the master we have the device state and several other informations. And every slave has also a state machine and has, for example, the link stage, which is available, for example, in the PLC. So the working counter, to start with this, is a type Boolean, so it gives you the information of if it's the state is 0, then we have a valid working counter, or it is true, 1, for an invalid working counter. So we normally do not check the working counter itself, so it's a number. So the master checks the working counter, the expected working counter, against the real working counter coming with the frame back, and gives you the information, okay, it's valid or it's invalid. Invalid working counter means that there is an EtherCAT command which is operated not in the right way, so that we have a problem with getting inputs or a problem with writing outputs. If you want to know exactly where it is, you have to do a special state check, for example. So you check the state of every slave to see which slave is responsible for the working counter error. Inside one EtherCAT datagram, inside one EtherCAT command, you have the working counter information of different slaves. So this is the general frame architecture. So we have the Ethernet header, then of course the different datagrams, and each datagram ends up with a special working counter, and the special working counter is always regarding to a sync unit. So it means we have one sync unit, one datagram, one working counter, and we get exactly the information about the validation of the process data exchange for every datagram. So this is a possible scenario. So we have a different set of terminals, and for example, a user, you can decide, okay, I want to have all the blue terminals in a special sync unit, the blue sync unit, the yellow in the yellow sync unit, and so on. So we, as a TwinCAT system, we decide to have hot connect groups in a special working group, in a special sync group, or to have, for example, the drives in special sync units. So this is done either automatically by the system or done individually by you. The next thing is that we have also bus diagnosis. So at the end of every frame we have a frame check sequence, and this frame check sequence has also a 16-bit CRC inside. So with every frame coming into the master, we check the validation of the CRC, and on the way through all the different slaves, every slave checks also the CRC on the fly. And if there's a CRC error, we can see this directly in the different diagnosis tools where the CRC error happens. And of course, CRC errors can happen because of cabling problems, contact problems, loose contacts, and so on. So we have two different things to check. One is the working counter for exchanging process data, and the second is the frame check sequence, or in special the CRC, to check really if the frame is valid or not. We check the CRC in every slave, so this means every frame is coming twice to a slave, one from the direction from the master and the way back to the master. The second time we see every slave. We can have slave with different ports, so a slave within a network, so a standard terminal, for example, has two ports, an A port and a B port. So the A port, we can see when the frame is coming from the master, it comes through the A port to the terminal, and on the way back we see the frame on the B port. Every EK 1100, so every coupler has three ports, A, B and C. We have also terminals with A, B, C and D ports. So for example the EK 1122. And so in the system manager part we see, okay, the special column for the CRC counters, and in this example on the right top we see terminal 3 has a problem at the B port of the terminal, and we see terminal 3 sees a CRC count at the A port of terminal 3. So between 2 and 3 we have a problem which ends up in a CRC error. We can also see in the system manager view the different tasks. So every task has an own frame. So we see here we have 3 tasks. So 500 microsecond motion control task, a 1 millisecond PLC fast task, and a slow 10 millisecond task. So every task generates own frames, and inside the frames we have own datagrams. And you see in the command column that we have different commands. So logical read-write command is the first command in the red frame. The special explanation, what is the meaning of every command, you can see in the basic documentation of EtherCAT. Every slave and also the master has implemented a special state machine, and the special state machine has different states. So we start with the init stage for initialization of master and slaves. Then we have pre-operational, which allows you to communicate to the slave, to set up the slave with special parameters via mailbox communication. Then we have the safe operational, where inputs are read to the master but no outputs are written to the slaves. And we have the operational state, where inputs and outputs are exchanged. And the special state is the bootstrap state, where it is possible to update a firmware on a slave. And in between, of course, we have different transitions from one state to another state. You can see the actual states in the system manager part, also in TwinCAT 3, of course, with a special view, the online view. You see the different slaves in the network. You see the state. And of course, normally it should be operational state. In this example, we see the first 3 are operational. The fourth is also operational, but see a missing link at the B port. And then we have a set of slaves which are not available in the network, so we see no communication. And then we have another column for CRC errors. And we have at the bottom the state machine for the master on the left side, so you can see the actual state, it's operational. You can also, via manual operation, switch the state to safe operational or pre-operational, for example. You can clear the CRC and also the frame statistic. And on the right side, at the bottom, you see the frame statistic with the different numbers for sent frames and so on. At the slave itself, you can do several settings, of course. So, for example, for analog terminal, you can see different things. You can adjust one thing, and this is important for the EtherCAT diagnosis, is the EtherCAT address. So this address is be used inside all communication stuff to get information from this special slave. You can always fix the EtherCAT address, and additionally you see for internal use the auto increment address, which is used when the system is starting up and scanning the network. At the bottom you see there's a direct link to the EtherCAT slave information file, and it is available on our web, of course. Every slave has also the actual state available as a parameter which can be linked to, for example, a PLC. And you see on the left side the meaning of the values inside the state. So normally you see the state variable in 8, which means the slave is in operational state. If not, you see on the left side different meanings of this value. Next thing is to where we can do EtherCAT diagnosis and how we can do this. So of course we start with the System Manager, which is available in TwinCAT 2 and also as a part of our XAE in TwinCAT 3, where you can see directly in one view the complete network, the actual state, the CRC, the master state machine, and also the frame statistic. So this is available, of course, for configuration for setting up a machine, but it's normally not available when the machine is running. We have the topology view, which is also possible to use. It's very easy to see in a graphical view. You see the topology, you see the different states, also the CRC can be seen. And we have, of course, also the possibility to do EtherCAT diagnostic via PLC code. So the TC EtherCAT lib or library is available and has several function blocks where you can directly do EtherCAT diagnostics. All is based on ADS, which means Automation Device Specification. So every master, every slave, you can do also via ADS the diagnosis, so you can get all information which is available in the System Manager or in the topology view, can also be accessed via ADS, and you can directly use this in your HMI, for example. So we start with the System Manager. So we see the slave state, we see the CRC, and what is pretty new is that we see also the changes, which means we see directly the changes from the different states. On the left side we see abnormal state changes. Perhaps the slave changes the state because it's out of sync for a drive. This is a normal state change. And on the right side we see state changes which can happen because of physical connection losses, a link loss, for example. We see this in the right screenshot above. So we have several states, and starting with slaves 10, we see that we have a link lost, and then we see in it no communication. So this is a state change which is normal because of a link lost, and we see then on the right side of the changes that the number is increasing. The change counters itself will be resetted with every TwinCAT restart. We can also see in the System Manager view the bus current consumption. So you see we start with an EK1100 with 2000 milliamps, and then every slave has, of course, a current consumption, so that we may end up with a negative current consumption, and this is the place where you should add EL9410, which refreshes the current with, again, 2000 milliamps. And then we start with the master diagnosis. So we have a beneath the master we see different items. So we start with the standard images for the different tasks. We have an info image which has a lot of information which is relatively static. Then with TwinCAT 3 we add our sync units tree. So we see different sync units, and you can directly map variables for sync units to your PLC code. And then we have the important thing is the inputs. So we have different inputs beneath an EtherCAT master, which should be mapped into the PLC. So for example, the frame working counter state for every frame is in this input image, but we have also a slave count in this image, and we have the device master state. So for the easy startup, you should check every frame working counter state, and if the frame working counter state is not equal 0, then you have a working counter problem, and then again you can check in the PLC where the working counter problem is coming from. Every frame has its own frame working counter state, so if you have 10 frames, you will see 10 different frame working counter states. You can also check the device state of the master. So also the device state has different return values. So if we see a 1, then you have a link error. And again, we have a lot of information in this device state, which is listed on the left side. If you need further information, check our website, and then you will see what is behind every different message. We have also the frame statistics. So we have in the frame statistics the number of sent frames, so the total number of sent frames. We have two columns. One is for cyclic frames, so every task sends a frame in a cycle. They are counted up, and this is cyclic frames. If you do acyclic communication, mailbox communication to a slave, this is counted up in the queued column. Then we have the number of frames per second, also for cyclic and queued. Then we have a counter for lost frames. So if TwinCAT sees a lost frame, so which means also if the frame has a CRC error, then this is counted up. And the last line we see on a very, very low level directly on the Ethernet network adapter, so the Intel chipset, gives us information about receive and transmit errors on a very low level, and this is counted up in the last line. So a lot of information for cyclic and for acyclic frames in the frame statistic. Sometimes not known is that we have also an emergency scan. So if you have really problems, and one of the problems could be that frames are not coming back, so that they are lost somewhere in the network, then we do not see the frame coming back, and we cannot do an analysis on the frame which is coming back. So we do not see CRC errors, we do not see what is inside the frame. If you have such a problem, switch the system to config mode, and then start emergency scan. And emergency scan means really that we send a frame to the first slave, and we do this not once, we do this 100 or 1,000 times. We see which frames are coming back or not, and we do this then for the next slave, for the next slave, and so on. And in this example, we see, okay, there is a problem before the 5th slave, so we see only 50 frames are coming back from 100 sent frames. So we can directly see, okay, there is a problem. On the slave side, we have also a lot of information available. So we have the slave state available, so you can directly map this to a PLC variable. Sometimes we have also ADS addresses available, not for every slave, but for some slaves. And of course, you can use this directly in your PLC. We have our EtherCAT topology view, which is directly seen directly from the system manager or from the XIE. This is internally used, but you can also use this in your application because it's an ActiveX control, and also documentation is available how to use the topology view inside your own applications. This topology view uses ADS, so you only need ADS to do this diagnostics inside your application. What can be seen with the topology view is a graphical view of the topology of the network. So starting from the master through the complete network, all the slaves are listed, also non-backoff slaves are listed. If you double click on the master or on the slave, you see further information. So for the master, you see the online view of the master, so the state of the master. You can also switch the state. You see the frame statistics directly, and on the slave you see on the top a bar which is normally green, which means the slave is in operational state. If the bar on the top is red, then you see, okay, we have a problem, so the slave is in init state. You see also a red box around the slave to really diagnose it, to get a diagnosis of the init state. You also see the CRC errors on this view. So you see red bubbles beneath the slave, which means we have CRC errors on this slave, and you can detect is it coming from the A port, the B port, the C port, or the D port. It's a very easy graphical view, less text, and a very easy and complete overview about the network. You see all the states, you see all the CRC errors, and this is very easy, and you can use this directly in your HMI, for example. If you double click to a slave, you'll see further information to the slave. So for example, the slave name, the type of the slave, vendor ID, revision number, and all this different product information. You see in the screenshot in the middle, you see, okay, the state machine of the slave. You can also see if there are CRC errors on the different ports. And on the right screenshot, you see that it's also available for process data. So you can also see process data of the slave inside the topology view. All is based on ADS. So for ADS, you need the EtherCAT masternet ID, then the port number, which is FFFF for the master, and the slave address for the slave. Then you need index group, index offset, and then you have complete access via ADS to all the different EtherCAT diagnosis information. The description of index group and index offset is documented in the TwinCAT information system. So the net ID, this is what you need, so to get access to the master, to the EtherCAT master, and then you need the information about if you want to talk to the master, then it's the port number is FFFF. If you want to talk to an EtherCAT slave, you need the slave address, which is then the same as the port number. So very easy to use. And of course, we use this also in the PLC function blocks, so it's completely done with ADS. We have same look and feel for all the different function blocks. So if you want to read COE, SDO, you can do this with the function block. And the same, of course, you can do for SOE. So the function blocks are available. You can read all the different CRC errors, slave addresses, or slave states. So it's one function block, so we get a big list array back from the function block with all the different CRCs, slave addresses, or slave states. So we can also change this slave state with one of the function blocks. So there's a request slave state. There's also a get slave state function block available. And what is also possible is that you can get a list of all the configured slaves, and you can compare this in the PLC with a list of all the scanned slaves, so that you can see if there is a mismatch between configuration and real physical available slaves. Also FOE, so file over EtherCAT, is available as in different function blocks, so that you can also do update of firmware via PLC code. What you need is always the information, okay, net ID and slave address. So here are the places where you find this information. You can directly copy this information to the function blocks, and then you can start executing the function blocks, and then you will get the values back. For the experts, it's also possible to go really on frame level. So we usually use Wireshark as a tool inside the Wireshark installation, which is available for free on the internet. There's a special parser for EtherCAT telegrams. The only thing you need on TwinCAT is that you have to switch on the promiscuous mode so that frames are doubled and that the frames can be seen in the Wireshark. If you start Wireshark, then you see a Wireshark window where you see all the different frames with all the timestamps. And if you double click to a frame, you see more information, and this is really directly the information from EtherCAT. So you see the different commands, you see the different datas and the different information directly, so that you can easily check how much frames are going around in the network and what is the content of the frame. But this is really for experts only. So summary for today is, of course, we have a lot of different diagnosis features implemented for EtherCAT, and they are all available, of course, in TwinCAT. So we support a lot of diagnostics features in the System Manager or in the XAE for TwinCAT 3. We see this in the presentation. You can use the topology view, which is a graphical, very easy to use view. You can integrate this view also in your applications, in your HMI, for example. But you can also access all this diagnosis information via ADS. Documentation is available in the TwinCAT part of the information system. And you can use, if you are a PLC programmer, you can use the function blocks inside the EtherCAT library. There's also documentation available, and there are also examples available how to do a very easy EtherCAT diagnosis in the PLC. So a lot of documentation is also in the internet available, and in this case we show you that the EtherCAT system documentation is available beneath the EtherCAT terminals. So one of the questions is, where is the ActiveX control for topology view available? So it's really available as a topology view, EC topology.dll, and you will find the documentation in the appendix of the System Manager documentation. So where to find the topology view and how to use the topology view. So this was the only question I got. So I thank you for your attention, and you will find this webinar also as a video in the next days on our homepage, so that you can easily see it again and listen to the different informations we have. Thank you for your attention, and bye-bye.